So, good evening. We have this lecture number 10, and that is revision lecture we have for design of steel structures. Now, in this, we have a heavy column is required to support a gantry girder, and a H section is fabricated. Check its suitability to support a factorial load of 1500 kilonewton, 10,500 kilonewton, assuming both ends are pinned. And we are interested to check its safety. So now this problem is again analysis. We are going to be problem with analysis. This is fourth problem. We have single angle, we have double angle, then we have ISHB column, and this is fabricated column actually. And we have here, this is welded. So this is H section, means we have three plates, and these three plates are connected to each other. So now we have to go with step one, and in this step one, we have to go for given data. So given data we have, that is factorial load is given 10,500 kilonewton. And we have to check safety of this. So this is, though load is given, but this is not design. Now length of column is also given actually. L is 8 meter. That was remained from my side. And now L is given. L is 3 meter. As both ends are pinned, so L effective equal to 3000 mm. Because we have K is equal to 1, KL we are saying, that is table 11. Now we will have now step 2 properties. Now we have to find A we have 2 into 500 into 60. So these are two flanges. So these are flanges. Plus we have 500 into 50, which is web. And then if we will calculate this area, we have 85,000 millimeters square. Then we have IYY, because minimum radius of gyration will be about YY axis, means about this axis. And then we have BD cube by 12. It is symmetrical. So H will not be there for both flange and web. So we have 60. This is our thickness of the flange. So you can see this thickness of flange is 60. So we have B as 600, 60 into D as 500 cube by 12. And we have two flanges. So multiply by 2. Plus we have 50 as B for web. Sorry, 500 we have. Now we have to go for this. So we have this as 50 millimeter. This is 500, and depth we have 50 millimeter. So B we have 500 into D is 50. So we have 500 into 50 cube by 12. And then from this we will get value, that is 60 into 500 cube by 12 plus we have 500 into 50 cube by 12. And we have this value 630.21. So we have 630.21 into 10 raised to 6 millimeter to the power 4. So we have, this will be IYY. Then what will be value of RYY, which will be minimum, R minimum under root of I by A. Under root of I by A. Then I we have 630.21 into 10 raised to 6 divided by area we have 85,000. And then we have 630.21 to the power 6 divided by 85,000. Root of this, we will have 86.1. Then we will go, that is KL upon R. So now KL we have 3000 and this R we have 86.1. And then we have 3000 divided by 86.1, 34.84. Then we will have step 3, classification. Then you have to go to table 2, page number 18, and you have to see first page 19. And in this page 19, we have B that is equal to, or we have B upon TF. Now B we have 500 minus 50 divided by TF, thickness of flange is 60. So we have this value, that is 450 upon 60, 7.5. Now this is welded section and we have this value B upon TF less than 8.4. Therefore flange is plastic. Now we will go D by TW. Now this will be as it is. So we have directly D now given 500, TW we have 50, which is equal to 10. Neutral axis we have, that is at mid depth. So this is less than 84. Therefore web is also plastic. Therefore section is plastic. And therefore AE equal to AE equal to 85,000 millimeters square. Now we will go to the next part, step number, we have step 4, and in step 4 we have to find value of FCD. So we have step 4. Design compressive stress. Sorry, step 4 we have buckling class. Now we have for buckling class B by TF we have calculated. Now we have to go to table 10, and in table 10 we have H by BF. So H by BF, and H, that is for, now we have for welded eye section. So we have to go for second row, and H we have depth of web, and H by, sorry, here we do not have any H by BF. We have only 2 clauses. So now be very careful. Buckling class for welded section. And it only depends on TF. So we have TF that is greater than 40 millimeters. And therefore about ZZ, we have C, ZZ axis, class C, and YY, class D. So for this actually we have taken this problem. So in welded you should not be confused, and therefore we have to use table 9D. And we have KL upon R and FCD. Now KL upon R we have already calculated 34.84. So KL upon R 34.84. So we require value that is 30, 30 and 40. So we will go to table 9D and there we have value for 30 is 204. And for 40 it is 185. And therefore we will get FCD equal to 185 plus 204 minus 185 upon 10 multiplied by base we have 40. So 40 minus 34.84. And we will get value of FCD and that is equal to 204 minus 185 divided by 10 multiply by 40 minus 34.84 plus 185 and we have 194.8 194.8 Newton per mm square. And then we have last step, step 6, design compressive strength. Compressive strength, and we have PD that is equal to AE into FCD. Now AE we have 85,000 and FCD 194.8, and from this we will get 85,000 into 194.8 and we have this value 16558 into 10 raised to 3 Newton. So 16558 kilonewton greater than 10,500 kilonewton. Therefore, column is safe. So likewise, we have to solve the problem of welded section. So now we will stop here only. So thank you.